How black holes trap light. In this episode, we explore a common misconception. Light isn't caught by black holes, but rather, it falls into a path of ever-steepening tension, finding no way back. According to energy filament theory, the region surrounding the black hole that mainstream physics calls the event horizon is actually a path of increasing tension. To light, it's not a wall but an infinite downward slope. Light follows the principle of least energy, always choosing the easiest path. However, near a black hole, all the easiest paths lead inward, with no exceptions. Imagine the black hole as a giant funnel. If you place a marble on the edge of the funnel, it won't be grabbed by the center. Instead, due to the incline, the marble rolls faster and deeper into the funnel. Similarly, light near a black hole follows this downhill motion, constantly pulled in by the steepening slope. Why is the slope so intense? In energy filament theory, the boiling core of the black hole, the cauldron core, continuously generates waves of tension. These waves push outward through the piston layer, which directs the waves toward the event horizon, forming an increasingly steep slope around the black hole. As light approaches the black hole, it initially can slide sideways, but the closer it gets, the steeper the slope becomes, and the harder it is to stray from the path. By the time light reaches the outer critical boundary, it's no longer moving forward but rather circling. The light's path is stretched to the point where it appears to never escape, and from a distant observer's perspective, it seems to be trapped forever. This is why light is trapped by a black hole. It isn't bound by chains or gravity but by a path that becomes so steep and costly to traverse that light is forced to spiral inward. Another analogy, imagine riding a bicycle downhill. The steeper the slope, the harder it is to stop. Near a black hole, the tension slope is the steepest in the universe, and light cannot turn around. So, black holes don't have hands, nets, or gravitational pull in the traditional sense. They trap light by guiding it along an increasingly deep tension terrain. Light isn't captured, it is invited in by the shape of the path. Next we'll discuss, why do all black hole shadows look the same? Why do all black holes in the universe appear to be molded from the same template? Tap follow, share it on New Physics, Clear Universe.